So, hello to the YouTube audience, basically everyone who's watching on YouTube. So, since no one has joined the session in person right now, so I'll be waiting for like 5 6 minutes before starting the session so that a few people can join the session in person also. So, yeah, I guess I'll get started in like 5 10 minutes. So, yeah. Hi Rasika. I guess since no one else has joined the session yet, maybe we can get started. So even if someone else joins the session, maybe we can uh, take his or her doubts along the way. So I hope my audio is clear to you. So if there are any issues, like always, you can mention to me via chat. So by the way, so just to reintroduce myself to the YouTube audience. So hello everyone. I am Lakshya Saggi, the NPTEL Competitive Programming Problem Solving TA for the Tuesday 6 to 8 p.m. sessions. So this will be our 11th session, and in this session we'll be covering the topics. We'll be covering problems related to dynamic programming. So basically, in the 11th week, and I believe in the upcoming 12th week also, there will be no new lectures uploaded for the NPTEL course, but rather we'll only be having like you'll only have assignments based on dynamic programming, and so we'll be basically solving problems related to dynamic programming only in these problem solving sessions for the for this session and the upcoming the session next week also. So yeah, I guess there's that. So I guess we can get started now. So I'll just share my screen. So just let me share my screen right now. Okay. So I hope my screen is visible, Rasika. If there are any issues, you can uh, mention to me via chat. Otherwise, I'll just assume everything is fine. So today, I believe it won't be very long. Like it won't take the session won't take like exactly 2 hours. It will be a bit shorter session because I have like something like 7 problems prepared. So it won't take a lot of time to cover these problems. So we'll try to address some of the doubts you guys might have. And yeah, so first let's come to these problems only. So these are the 7 problems which we'll be discussing. So the first problem says that a subsequence of a given sequence is a sequence that can be derived from the given sequence by deleting some or no elements without changing the order of the remaining elements. So, what's the definition of subsequence? I believe you guys must have gone through this in some of the lecture videos, some of the problems earlier also, but I'll just define this uh, again also. So, basically, a subsequence is just a subset of the a subset of the given sequence where the numbers are in the same order in which they were in the original sequence. So for example, consider let's say consider an array, let's say uh, 1 2 3 4 5. So this was an array. Then some possible subsequences. So what are the possible subsequences for this array? So they are, so essentially you have to select a subset of these elements while maintaining their relative order. So let's say I select the elements 1 and 3. So the subsequence will be in this order. So 1 comma 3 will be a subsequence. Note that 3 comma 1 won't be a subsequence. And why is that? Because even though 3 and 1 both appear in the array, but these 3 and 1 appear in this order, that 3 comes after 1. So uh, 3 will have to come after 1 in the subsequence also, which is not the case here. So this won't be a subsequence, but rather this 1 comma 3 will be a subsequence. So note that the numbers don't have to be contiguous. It doesn't have to be necessary that if I have picked 1 and 3, then I also have to pick 2. So like 1 2 3 is one subsequence, 1 comma 3 is another subsequence. So 1 3 is a subsequence, 1 2 3 is a subsequence. Similarly, maybe 1 3 5 is a subsequence. Some subsequences might not even contain one. So like just the subsequence, let's say 2 comma 5. So yeah, etc. So all of these are like examples of subsequences. Uh, so I hope you understand what's the definition of a subsequence. So yeah, so this is what we call a subsequence. And now the problem asks us, consider the following algorithm to find the length of the longest strictly increasing subsequence. So, uh, so what we want to find out is the length of the longest strictly increasing subsequence from the array A. So out of all the possible subsequences, we have sorry for that, guys. So, so out of all the possible subsequences, we have to find out the longest subsequence in which all the numbers are in strictly increasing order. What do you mean by strictly increasing? That no two numbers are equal, and the number next to, like, if A and B are numbers and B is after A in the subsequence, then B should be greater than A. Okay, okay, and now we have to find like something like this, like we have to find the length of the longest strictly increasing subsequence in the array A. So just to get an idea of the difficulty of this problem, so suppose I go brute force. I apply a brute force approach, which is like something like let's enumerate all the possible subsequences of the array and then try to find out the subsequences which are actually in increasing order, and out of those select the longest one. So just as an exercise, so like suppose the array has length 5, then what do you think will be the number of possible subsequences in the array? So let's say in this array A, how many subsequences are possible? So note that a blank and empty list is also a subsequence of this array, because if you don't select anything, that's also a valid sublist. So just as an exercise for your like combinatorics, just as a revision of combinatorics, you may say, uh, suppose the array has length 5. So any guesses, Rasika? Like, what would be the number of possible subsequences in this array? Okay. So Rasika is saying that there would be 6 possible subsequences. So, are you sure, Rasika? So, I believe I have written 1, 2, 3, 4 examples of subsequences here only. And I believe I can write much more also, like 1, 3, 1, 2, 3, 1, 3, 5, 2, 5. Similarly, I could have written something like a 1, comma 2, a 2, comma 3, and something like that. So it's like it would be a lot more than 6. Okay, so Rasika is typing something. Yeah, it would be more than 6. So to count how many subsequences will be possible. So what you we can use a combinatorial argument, like I'm just doing this to like it's sort of a revision for combinatorics, you can say, or just for the fun of it. So what you can actually see is, so while selecting a subsequence, what we can do is we have a choice for every element. Like for this one, for this two, for this three, four, five, we have a choice for all of these elements, whether we can select the element or we don't select the element. So either we can select this one or we don't select this one. Similarly, either we can select this two or we don't select this two in our possible subsequence. Similarly, either we can select this three or don't select this three. Like in the subsequence 1, comma 3, we have selected 1, not selected 2, selected 3, not selected 4, not selected 5. So actually each element has like two choices. Each element of this array has two choices, whether it is included in the subsequence or whether it is not included in the subsequence. Because if they are included, then so the elements which are included will have exactly one subsequence. Like if 1 and 4 are included, then 1, comma 4 will be a subsequence. Similarly, only 1 and 3 are included and all others are excluded, then 1, comma 3 will be a subsequence. So actually, every element in the array has two choices, and like each choice which we make results in one subsequence. And how many possible choices will be there to form this array A to form a subsequence? So every element has two choices. There are 5 elements. So the number of choices will be something like 2 times 2 times 2 times 2 times 2. like something like 2 raised to the power 5, which is 32. So like this array A, an array of length 5, will have 2 raised to the power 5 possible subsequences. Similarly, for an array of length n, so there will be two choices for every element, and there are n elements. So there will be 2 raised to the power n possible subsequences for an array of length n. So this this I just mentioned to get an idea of how many subsequences are actually possible. Like if one tries to find out all the possible subsequences, it would take at least 2 to the power n time, because an array will have 2 raised to the power n possible subsequences. So yeah, so that is something we don't want to do. We don't want to take this much time. Exponential time is generally very bad for us. So what do we do then? So we try to solve this problem using dynamic programming. So how do we do this? So we are given some structure, and we have to fill in the blanks. So yeah, so we are given some piece of code, and we have to fill like how do we solve this problem actually. So we consider the following algorithm to find the length of the longest strictly increasing subsequences. And how do we do this? First, let's just get some notation out of the way. So let's say LJ denotes the length of the longest strictly increasing subsequence ending at AJ, where J is between 0 to n minus 1. So we have an array of length n, a zero index array of length n, and we store the variable lj, which just says like which just stores the length of the longest strictly increasing subsequences ending at aj. So if aj is at the end, like let's say in this example, we consider the number 3. So a strictly increasing subsequence ending at 3 will be like this subsequence 1 comma 3, 1 1 2 3, and similarly there may be more subsequences, and we just store the length of the uh, longest possible strictly increasing subsequences which end at aj. Like if aj was 3, then which end at 3. So something like that. And we store this for all possible j from 0 to n minus 1. Okay. And like if we are able to, so we for to actually calculate this, we'll need something like dynamic programming or something. Like it is not obvious, like right key that how do we find this lj actually? Like given some aj, or let's say given some j, how do we find the value of lj? So for that, we'll be needing something like a dynamic program. And yeah, so the algorithm, high level algorithm is given to us. And this algorithm says that let's just assume that n is equals to the length of a. So n denotes the length of the array a. And now let's initialize the list L0 to n minus 1 equals to 1. So this means that initially the list L, which actually the list L which stores these values for all j's, let's say it has value just equal to 1. And why is this 1? Because at least we know that Lj will be equal to 1 for all possible j. Because let's say if we want to find a subsequence ending at 4, so just a 4 will be a subsequence also, right? And it will have length 1. So it will be at least 1, we know. So I hope it's clear like why this will be at least 1. Maybe initialization doesn't matter much. Mainly what matters is the recursive relation, but it's just good to keep in mind that these values will be at least equal to 1. And now what we are trying to do is we are taking two nested for loops, and for in first for loop we take for all I starting from index 1 to n minus 1, and in second for loop we start for all j starting from 0 to I minus 1. And now we use some inductive structure, or let's say some recursive structure, and we have to fill in like what will be this recursive structure be if we want to find out the length of the longest strictly increasing subsequence. And then like we just need to return the max of L. So suppose we are able to calculate this. Suppose we are able to calculate this array L, where Lj is the length of the longest strictly increasing subsequence ending at Aj. Then if we want to find out the actually the length of the longest strictly increasing subsequence in the array, so like rather than always saying something like this longest strictly increasing subsequence, I'll use just the term LIS, longest increasing subsequence, and it will be assumed it is implicitly strictly increasing. So to find the length of LIS, if I'm given this LJ array, then it's quite easy to see that we know that every subsequence ends at some value, right? So there will exist some J for every subsequence at which that subsequence will be ending. So what this actually means is that if we know this Lj, then the length of LIS will be just the maximum over all possible LJs, because every subsequence has to end at some J, right? So that's why if we are able to obtain this array L, then the answer for the length of LIS will just be maximum of L. So we know from line 6 that we are just returning max of L. First line just initializes N. Second line just initializes the list L. Then third, fourth lines are just for loops. And in fifth line is the main recursive structure which we need to find. And in sixth line, we are just returning max of L. So the only task which remains for us is to actually find, like, know how do we calculate this L. Like, this L is something we don't know how to compute. Like, we don't know how to fill up these entries Lj. And this is what we'll be doing using dynamic programming, let's say, or using recursion. So, so there are four options. Like, so suppose we want to find out the value of Li. So if I want to find out the value of Li, so what will the value of Li be? So how do we find out the value of Li? So we go from for all j starting from 0 to I minus 1, we compare Li with something like Aj and something, and we try to update the values. So any guesses, Asika, which of these would be a good fit for the inductive structure which we want to use to find the length of LIS? Okay. So Rasika is saying that answer should be C. And what is the option C? Option C says that Li equals to Lj plus 1 if Ai is greater than Aj and Li is less than Lj plus 1. So yeah, Rasika, actually I think you're correct. So maybe I should first write down the answer and then maybe I can discuss the solution also. So good job, Rasika. So answer will be something like option C, and maybe I should just underline this also. Okay. And why is this the correct answer? So what do we want? So Li, what does Li store? So Li just stores the uh what we want the Li to store is length of length of the LIS ending at AI. So by Li, we just want like the if ith element is the ending element, then what is the maximum longest possible subsequence, increasing subsequence, right? So essentially, we have fixed that the last element for the subsequence will be AI. And now what we actually want to find out is if we know the last element is AI, then we have to just find out the remaining possible elements, right, of the list. So what I'm trying to say is maybe, so let us suppose these are some blank spots which we need to fill, and we know that we already have this AI with us. So we know that in the subsequence, the last element will be AI. And now what we want to do is we want to find out the remaining part of the list, like what will be the maximum possible length of this list. So for finding out the maximum possible length of this list, so suppose uh, the second last element is some element aj. The second last element of this uh, LIS ending at AI is aj. So actually, what I claim is this part, the part which I've highlighted, will actually be its length will actually be equal to LJ. LJ is the length of longest increasing subsequence, which is ending at AJ. And why is this the case? Because the part which I've highlighted is also a subsequence, and this subsequence ends at AJ. And this will be longest possible since LI is the longest possible. Since this is the longest possible ending at AI, so this will be the longest possible ending at AJ. It can be shown easily. So what this essentially means is that Li will actually be equal to nothing but Lj plus 1. So this will be Lj and we are adding the element Ai to it. So the value of Li will be nothing but Lj plus 1, which is reflected in all of these options. But note that some of the constraints will be, one constraint will be that Ai should be greater than Aj, strictly greater than Aj. And why is this? Because we are only interested in finding out the longest strictly increasing subsequences. So for strictly increasing, we know this part is strictly increasing, but we also have to ensure that AJ is also less than AI. So that's why AJ is less than AI. And also, and this part is just updating the value of Li whenever Li is less than Lj plus 1. Since we want to find out the maximum possible over all J's, we are just updating this part as Li is less than Lj plus 1. So that's why this option C is correct. I hope it's clear to you guys. Maybe I can write a few words of description for it also. But I hope the main idea is clear to everyone. If it is not, then maybe you can ask in chat also. But yeah. So we can easily show that. Okay, maybe I should not write it like this. To calculate AI to find Li, consider the longest strictly increasing subsequence ending at AI. Then the second last then the second last element of this subsequence will be some j will be will second last element will be aj for some j, and the conditions will be that aj is something like less than ai. This is because we need a strictly increasing subsequence since the subsequence is strictly increasing. And also the length of this subsequence Li is equals to Lj plus 1. So because like till Aj there were Lj elements and now we have added 1, so there will be Lj plus 1. So for all j such that Aj is less than Ai, uh, so over all j, we take the maximum of Lj plus 1. So, so over all j such that aj is less than ai, what we are doing is we are just computing the value of Lj plus 1 and we are just taking the maximum possible over all j's which follow this. And this is what we call as ai. And this is equal to L. So yeah, and this is what option C is doing. And how is option C doing this? So just to be clear again, so this AI greater than AJ part filters out all J such that AJ is less than AI. And then for finding out the maximum of LJ plus 1 over all J, this part, the Li is less than LJ plus 1 condition takes care of this. So yeah, I hope this argument is clear. If yes, maybe we can move on to the next question. Okay, so second question is again based on an application of this first question only. Second question is just stating that consider the input array given to us as this. So here we are given this array A, which has length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So an array of length 12. And now we want to find out the length of the longest strictly increasing subsequence of numbers in the array. So what we want to find out is, so we have discussed an algorithm here to find out the length of longest strictly increasing subsequence. And now in this problem, we are actually required to sort of implement this algorithm on this input array A. So this is just to get a feel of the algorithm, like what this algorithm is actually doing. That's why we have this sort of question here. So maybe we can do this question. So it is. So let's just see maybe. So let's just consider that array 0 index. Consider that the. So let us assume that the array is 0 index. So 0 index because I'm just saying that this will be 0th element, this will be first element, this will be second element. So this element will be A0, this will be A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, and A11. So what this actually means is let's just construct the array L. So what will be the value of L0? So L0 is nothing but the length of array which ends at directly A0. So the subsequence, the length of the longest strictly increasing subsequence which ends at the first element itself. So it will just be 1 because there is only one element present and that can be considered in the subsequence. So L0 will be 1. Now, what will be the value of L1? Maybe I should write first here also to solve this. We construct the array L and take the maximum over all possible entries of sphere. We are doing something like this. So now what will be the value of L1? So L1 will be this 11. So what we do is we just take all the elements which are less than 11 on the left side of the array. So there is no element present which is less than 11 on this side. So it's just again set to 1. So okay, yeah. Similarly, now let's take L2. So what will the value of L2? So we again for this 8, we take the or we first consider all the elements which are less than 8 on the left side of the array. Again, we have no elements. So what this means is that 8 will itself form a subsequence like uh, of length 1. So again, L2 is nothing but a 1. Now we take L3. And what does L3 entail? So L3 is this. So for calculating L3, we'll need this entry. So for this 10, we again see what values are actually less than 10. So out of 12, 11, and 8, only 8 is less than 10. And this 8 will, and the value of, so this 8 is at the second position. So the value of L2 is already 1. So when this 1 is combined with this 10, this length will become actually equal to 2. So L3 is equal to 2. Similarly, coming to L4. So what will the value of L4? Maybe I can take this question on the next page so that all the calculations are on the. So yeah. Mm, okay, maybe I should just copy this first. L4, L5, L6. So this was, we first find out L4, then we'll find out L5, then we'll find out L6, then we'll find out L7, then L8, then L9, L10, and then L11. And these are the 12 entries which we want to find. So to find out L4, so L4 will be something. So this will be the L4, like the fourth index element, because this was 0, 1, 2, 3, 4. So what J's are less than 13? So what values are less than 13? So this 10 is less than 13, 8 is less than 13, 11 is less than 13, 12 is less than 13. So all these values are less than 13. And out of these, we take the maximum value, which will be just 2, and we just add 1 to it. So 2 plus 1 will be nothing but a 3. So this will be 3. And now we come to L5. So what will be L5? L5 will be this 0, 1, 2, 3, 4, 5. So L5 will be something like this, the 33. So again, we say all the j's such that the age is less than 33. So this 13, 10, 8, 11, 12, all of these are less than 33. So for all of these j's, we just take the maximum j, which will be this 3, and we just add 1 to it. So 3 plus 1, which will be equal to 4. And similarly, to find out L6, so this will be the sixth element, like 0, 1, 2, 3, 4, 5, 6. And to find out, so what values will be less than 29? So 33 is not less than 29. 13, 10, 8, 11, 12. So all of these are less than 29. So we take L0, L1, L2, L3, and L4 and take the maximum out of those. So out of L0, L1, L2, L3, L4, the maximum is this 3. So 3 plus, we add 29. So 3 plus 1 is equal to 4. So we append 29 to the sublist. So 3 plus 1 will be equal to actually 4 now, because sublist becomes of length. So now we come to L7. So this number is 21. So again, what indices are less than 21? So 29, 33 are not, but these are. So 0, 1, 2, 3, 4. So out of from L0 to L4, we take the maximum possible, which is again 3 only, and we add 1 to it, which will give us a 4. Similarly, now coming to L8, so L8 will be 0, 1, 2, 3, 4, 5, 6, 7, 8. So for this, what we can actually do is again see all the numbers which are less than 30. So 21 is less than 30, 29 is, but 33 is not, and all of these are. So L0, L1, L2, L3, L4, the maximum out of these is 3. And now out of these 29, and so this is L5, which is greater, so we won't consider this. But from L6 and L7, we'll get the maximum equal to 4 now. So not just 3, but the maximum will be 4. And we add 1 to it for 30. This L8 will be actually equal to 5. So I hope you're able to follow along like what I'm trying to do here. If you're not, like, you can just ask me via chat, Rasika, and I'll try to explain it again in a better way. So let's come to L9. So otherwise, I'll just assume that everything is going smoothly, and yeah, you're able to understand. So now coming to L9, again, we see that actually all the indices are less than 41, like 30, 21, 33, everything is less than 41. So we just take all the indices and take the maximum L value, which is the 5, which was L8. So 5 plus we add 1 to it. So 5 plus 1 is 6. So we get L9 equal to 6. Now coming to L10. So this is 60. So again, we see that all of the previous values is actually less than 60. 41 is less than 60, 30 is less than 21. So all of these values are less than 60. So again, we take the maximum out of all these values, which will be this value 6, because like out of all these 6 is maximum. So we add 1 to it. So we get a value of 7. Okay. So now coming to the L11. So L11 will be this 55, and we need to see so we first need to find out the indices which are less than 55. So all indices except 60 will be less than 55. So all of these values will be less than 55. Only this value is greater than 55. Only this is 55. So what we do, we ignore the L10 index, and out of all the previous indices, we just take the maximum possible. So out of L9, L8, L7 and all, we take the maximum possible index. We take the maximum possible value, which will be the value 6 for L9. And we just add 1 to it. So again, L11 will be equal to 7. Okay, so what we have done is we have constructed this array L. So we have essentially, we right now know like what's the maximum possible subsequence length ending at L0, L1, L2, L3, and so on. So now to find out the length of longest possible strictly increasing subsequence from the whole array, what we need to do is we just need to take the maximum over all possible entries of L. So we just need to take the maximum over all these values. So the values are 1, 1, 1, 2, 3, 4, 4, 4, 5, 6, 7, 7. So maximum, see that maximum is 7, either this or this. So hence, as the maximum value of L is 7, hence the length of the longest strictly increasing subsequence of numbers in A is equals to 7. So, so actually 7 is the correct answer, and maybe I'll underline it also. So everyone. Yeah. Something like this. Okay. So I hope it's clear. And yeah, maybe if it's clear, we can move on to next question. So again, like previous question, we again have a common problem statement for questions 3, 4, and 5. So what does this statement say? So common statement for question 3, 4, and 5 is something like this. Uh, Consider the following function do something, where a and b are two strings of length m and n. So this is a function which is given to us. We don't know what this function is doing. It's just doing something. So this do function something takes as input two strings a and b of length m and n. So m is equal to length of a, n is equal to length of b. And now this initializes a 2D array, a 2D table effectively, which has something like n plus 2 rows and m plus 2 columns or something like that. Maybe, yeah. It has something like m plus 2 rows and n plus 2 columns. So yeah. So this is an array T. So this is a table T which we initialize. And how is this table T being filled? So initially this table T has all entries as 0. And so then we like move for I, then we traverse for all I and j in increasing order. Like so for all I in range m plus 1, 0 to m plus 1, for all j in range 0 to n plus 1. So we just see that if I equal to 0, then Tij is set to j. If j equal to 0, Tij is set to 1, Tij is set to I. Else if ai minus 1 is bj minus 1, then Tij is set to t1 plus ti minus 1 j minus 1. And else Tij is set to 1 plus minimum of Ti minus 1j, comma, Tij minus 1. Okay. Maybe I should put this in the X. Yeah. So now the question actually asks us, so this question 3 actually asks us uh, that what does this function do something actually doing? Like what does this function actually return? So this is the function which we are talking about. And now we need to find out like what actually is this function doing. So maybe we can try to see it ourselves, like what this function is actually doing. So what we are trying to do is maybe I should insert just a table for just a reference of uh, to just simulate a 2D table, which is being done in this problem statement. So maybe just let's just take this table for example. So what is this doing? So it's initially setting all the entries as 0. So I'm just doing an example run of this array of like, maybe not an example run, or I'm just yeah. So I'm just setting the entries of all t as 0. And now what we are doing is for all, so for all I in range 0 to n plus 1, for all j in range 0 to n plus 1. So essentially we are traversing the array in this order. So first we are first we are talking about this cell, then we are going to this cell, then we are going to this cell, then this, because I is 0 and j goes from 0 to like n plus 1, so something like this. And then we go to this part, this cell, then we go to this cell, then this, and so on. And how are we updating the entries for all these cells? So if I is 0, so in the first row, we said Tij just equal to the column number j. So this will be, so column number here will be 0, column number here will be something like a 1, this will be 2, this will be 3. So something like this. And if j is 0, then we set Tij equal to I. So if j is in the first column, we set uh, the entry equal to the row number. So something like this. And now what we do is if ai minus 1 is equal to bj minus 1. So we were given these strings a and b initially. So if like while we are computing an entry ij, for computing an entry ij, what we are looking at is the I minus 1 and j minus 1th part of the string. So if they are equal, then we just set Tij equal to 1 plus Ti minus 1 j minus 1. So if this condition is satisfied, like Ai minus 1 is equal to Bj minus 1, then what you are actually doing is we are just setting the value of cell as just the entry just diagonally above it plus 1. So if this entry was 0, then this will be 1 or something like that. So we are doing something like this. And else we are doing something like Tij equal to min of 1 plus uh, so min of Ti minus 1j. So like let's say this was ij. So this else part is doing something like take these two cells, take the minimum of it, and add 1 to it. And in the end, we are just returning tm command. So the entry is what we are returning. So I hope you get the flavor of the traversal which we are doing, like, or at least I'm not saying you get the algorithm what we are trying to solve, but at least you get the idea of how are we updating the table entries, at least. Okay, so we know that this returns something, and now the problem is asking us what does it actually return? So what does the function do something actually return? So maybe we can get some idea from the options itself. So, or maybe let's say we don't consider the options, we try to think about it ourselves first. So, okay. Hmm, okay, maybe it's a better idea to see this using these options themselves. So the part A says length of the shortest possible string S, where A and B are subsequences of S. B part says length of the longest common subsequence. C part says length of the longest continuous common sequence. And D part says edit distance. So, do you guys know the definitions of these, Rasika? So, do you know what is edit distance, or do you? Uh, have you come across this term edit distance between A and B? So, what does edit distance mean for us two strings? Okay, so not sure. So, edit distance is nothing but so. What does edit distance mean? So, suppose you are given a string A and you have to and the operations you are allowed to do is maybe replace a character of this string by another character, or you are allowed to insert one more character into A, and you're also allowed to delete any character from A. So there you are allowed three types of operations: insert, delete, and replace. So if you are allowed these three types of operations, then what is the minimum possible number of steps in which you can convert A to B? So maybe I should just explain what edit distance is. I don't know if this is relevant to this problem also. Like, I don't know if D is actually the correct answer. Maybe we'll have to find out. But for two strings A and B, edit distance between A and B is equal to the minimum number of operations needed to convert string A to string B. And the possible operations, the operations which can be done are insert a character in A, delete a character from A, and the third possible operation is a replace a character in A by some other character. So I don't know how useful will this be for this question, but this edit distance is an important notion, and I believe you should. Uh, this is an important notion in strings, so you guys should know at least what does edit distance mean. So yeah, so just keep this in mind. And so now, what does this function a comma b actually done? So what is this function actually doing? So if j is actually equal to 0, so for the first row, first column, it's just setting these entries as 0, 1, 2, 0, 1, 2, 3. And then the main thing starts. So it says that if a I minus 1 and b j minus 1th entries are same, so if I minus 1 and j minus 1th entries of the two strings are same, then what we are doing is we are just adding 1 to the I minus 1 comma j minus 1th entries. Suppose uh, and otherwise what we are trying to do is we are just doing tij is 1 plus minimum of ti minus 1j and ti comma j minus 1. So maybe we can take an example run of it. So let's say it would be better if we can take an example run, right? So let's say so we have n plus 2 rows, and so we have something like m plus 2 rows and n plus 2 columns. So what we can have is A is let's say 2. So A is of length 2. So let's say A is a string AB and B is nothing but the string. Maybe I should just extend this table a little, like so that we can get a better idea of insert row. Okay, so insert row below, insert column right, something like this. So 0, 1, 2, 3, 0, 1, 2, 3, 4. So I'm just trying to simulate this algorithm, and while simulating, we'll get an idea of what this algorithm is actually trying to do. I already have understand the idea and I understand it intuitively what the answer should be, but maybe I should show it to you guys also. So yeah. So just consider the string A as AB and consider the string B as maybe just consider A as ABA and second string as just 8 or maybe AA. So yeah. So how are we updating the values? So if I was 0, we just said Tij equal to j. If I was 1, we said Tij equal to I. And otherwise, what we are doing is if ai minus 1. So let's consider for uh, let's consider for I is equal to 1, because I equal to 0, we have already set the values. If I equal to 1 and j equals to 0, then we have already set the value. So if j equals to 1 and I equals to 1, so we are looking at this value. So for this, what we are doing is if A 0, so I is 1 and j is 1 currently, remember. So I minus 1 will be 0 and j minus 1 will be 0. So if A0 is equal to B0, so what's the value of A0 here? A0 is this A and B0 is also this A. So actually both of these are equal. So right now we are into this condition. Then what we are doing is we are Tij equal to 1 plus T of I minus 1 j minus 1. So this value is just equal to 1 plus the value present above, which is 0. This will be something like a 1. So I hope you see what I tried to do here. Similarly for t0 comma, so here right now in the next entry we have something like I equals to 0 and j equals to 2. So for this entry, so I is equal to 0 and j equals to 2. So I minus 1 will be, so I is 1 and j is equals to 2. So I minus 1 will be 0 and j minus 1 will be 1. So again, we compare A0 and B1 now, and we see that these two are also equal. So I hope you see like so we have to here compare like A0 and B1 because J equals to 2, whereas I equals to 1. So we have to find out this value, and this will be nothing but 1 plus the, again 1 plus the value of the previous. So 1 plus the diagonally above 1. So 1 plus 1, which will be 2. So here, what we'll have is so here we'll be having something like I equals to 0 and j equals to something like 3. So if j equals to 3, then j minus 1 is 2. Okay, have I did some mistake? Uh, okay, so I don't see why are they making an array this large. Maybe let's just say we have this array as this large length. So, so ABA should be the array A, and okay guys, maybe I did a bit of a mistake. Sorry for that. So the array B, so array B has length 2, string B has length 2, so n will be equal to 2. So there will be 4 columns and not 5 columns. So this column won't be there. But instead there will be something like m equals to 3. So there will be something like 5 rows. I hope you see what I'm trying to say. So there will be only this much columns. Okay, I should just delete this. Sorry for this. And there should be this much rows. I think this is good. So yeah, because there are something like m plus 2 rows. So m is 3. So there should be 5 rows. So yeah. So now we are trying to come and how many columns are there? So columns are n plus 2 columns. So there should be like something like 4 columns. So we have these 4 columns, but I don't know how useful will these be. So right now we had so I only goes from 0 to m plus 1, where m plus 1 is nothing but 4 because m is equal to 3. So maybe we can just write down m equals to 3 and n was actually equal to 2. So I just goes from 0 to something like 3. And 3 is also like it's open at 3. So it actually goes till 2 only and it does not go till 3. So the similarly here it goes only till 2, it does not go till 3. So here we had something like j equals to 2 and I equals to 1. So this case has already been resolved because after this at this cell j will be actually equal to 3 and 3 is not allowed because we have something like less than n. We can only go till less than n plus 1. Like n plus 1th iteration is not allowed. So we are only allowed to go till j equals to 2 and at j equal to 3, the loop will actually break. So we don't want, so this value won't get updated. So now I gets updated to 2. So when I equals to 2 and j equals to 1, we have something like again comparing a of 1 and this b of 0. So this will be actually equal to 1 plus t of I minus 1 j minus 1. So it will be 1 plus this value. So this will be 1 plus 1, which will be 2. Similarly, when we go here I equals to 2 and j is also equal to 2. So here what happens is we look at a1 and b1, which are again not equal. So we'll again say that it will be 1 plus the value which is present here, which is 1. So we'll again say that the value here is 2. And now j will update to 3, and so we won't go to 3 right now. So now I goes to like 3 now because and this is the last step at which I can go because m equals to 3. So when I equals to 3 and j equals to actually 1, what happens is uh, so if j is 1, then what happens is we compare the b0 and a of 2. And these are equal. So if these are equal, then we just say it is 1 plus the diagonal entry. So it will be 2 plus 1, which will be 3. Similarly, here what we do is uh, again we'll see that these two are equal. So again we'll do 2 plus the diagonal entry, like 1 plus diagonal entry, which will be 2 plus 1, 3. And now it won't go till here because j becomes 3 here. Similarly, it won't go into this side also because I becomes 4. So this is the table which the function computes for these a and b. And then it returns basically m comma n, t of mn. So it just returns the third row and second column, which will be this cell. So this function actually returns the value 3 for this input, ABA and AA. Okay. So, and what does this 3 entail? So length of the, so let's just see maybe what does this 3 even mean here. So A option says length of the shortest possible string where A and B are subsequences of S. Okay. or B option says length of the longest common subsequence of A and B. So note that the two strings which we used were ABA and AA. So the longest common subsequence, so we know already what a subsequence is. The longest common subsequence will be just a the subsequence occurring in both A and B and of maximum possible length. So it is easy to see that AA is the longest possible subsequence. But AA's length will be just equal to 2. So, but what we have obtained for this example from this function is 3. So we can already rule out this option B here. And what does the long option C say? Length of the longest contiguous common sequence of A and B. So again, so we want to find out longest common sequence of A and B. So since B has a length of 2, so this sequence can't have a length more than 2, right? Because it is a part of B. Something a part of length 2 can't be greater than 2. So this option is also ruled out because we have the answer as 3 already. Similarly, edit distance between A and B. So here note that to convert A to B, we just need to delete this small p. And then A and B will both be equal to double A. So using just one operation, we can convert A to B. So edit distance will actually be equal to 1 and not 3. So what this actually means is that options B, C, D, all of these three are eliminated just by this example. So what remains is actually just this option A. And obviously this is not a good idea. Like, so since this was just a multiple choice question, we were able to eliminate the options using just an example and just filling up the values. But ideally, we would also like to understand the logic behind this also, right? Why is this program giving us something like this? So for now, we know that the answer option A is correct because uh, all other like for this input, all the other options are failing. So yeah, by a method of elimination, we arrive at this as the correct answer. Maybe we can just see also why this is the answer. Like why is this actually correct? Like why is this DP program giving us this value for the string? So what do we have to find for this option? We have to find length of the shortest possible string where A and B both should be the subsequences of that string. So what does this actually mean? So this means that we have to find a string. Uh, we have to find a very long, let's say a string S, so that A and B both occur as subsequences of that S. So one trivial string can be just appending B to A or A to B. So like the string capital A followed by the string capital B. So a string ABA, AA will always have A and B as substrings, as subsequences. But what we want is the length of shortest possible string. And the main idea behind finding such a string is first we need to find out the DP relation for this, right? And actually, you will see that DP relation for this comes out to be equal to this only. Like this will be the DP relation if we want to find out length of shortest possible string S. And maybe this can be a homework for you guys to figure out. From the example run for A and B, it is easy to eliminate for A equals to ABA and B equals to AA. It is easy to eliminate options B, C, D as all these have value less than equal to 2, whereas do something A comma B returns the value 3. So option A is correct, is the correct answer. by, as it's the only remaining option. So this is okay. Like this argument is okay if we are in an exam type setting, but we also need to, but we sort of also need to find out, uh, like why is this actually correct. So we are just not here to solve like know how to fit in the correct option. We also want to understand the theory behind it, right? So maybe do it. I can give it a do it yourself. Do it yourself. Uh, why does do something A B return the sh- shortest possible string S such that A and B are subsequences. So this is a good exercise to see yourself, guys, because this will help you understand dynamic programming a bit more. So just to give you guys an idea, so what we want is a shortest possible string such that A and B are subsequences of S. Okay. So to construct this string, let's just consider this example only. Let's just see what we have to do. So suppose the last characters of A and B are matching. Suppose capital A and capital B last characters are matching. Here they indeed are matching. So this small a and small a are matching. So what this actually means is that in our resulting string, in our final string S, what we can do is we can set the final character to this character itself. The final string S can have this single A as the final character. And then and for the remaining part of the string S, we just have to find out we just have to recurse on these parts of the strings, the part AB and for capital B string, the part. So for these two strings now, we have to find out the shortest possible string S, and then we just append small a to that string, and we'll obtain the string for this ABA and AA. So that's why it's saying that if AI minus 1 and BJ minus 1 are equal, so if the last entries are equal for the strings, then just add 1 to the T of I minus 1, J minus 1. So just add 1 to the solution of this. To this instance, A, B, and A instance, just add 1 because we are just adding one small a to that. And and to solve this instance, let's say A, B, and A instance, what we actually want is we know that the last element of the string S will either be this B or this A because they have to occur as subsequences. So we just take two cases. One case where this small b is the last character. Then we just have to find out for this AA case now. And the other case is when this small a is the last character. And then we just have to find out this for this AB and the blank string now. That's what this part is doing. Else 1 plus min of ti minus 1j comma tij minus 1. So once we take the last character as the last character of the first string, and second time we take the last character as the last character of the second string, and we take the minimum over those since we want the shortest possible string, and we add 1 to it because we need to append one more character, right? So this is how we obtain this else part. So I hope on a high level this elif part and this part is clear, like how do we arrive at these recursive formulations. And yeah, maybe you can see this rigorously yourself also, but yeah, this is the high level idea. Like if last characters are equal, then you just need that to add that character to the remaining sub problem. Otherwise, you need to take the last character one by one from both the strings and add one to it. So yeah. Okay, I hope I made a bit of sense. If not, maybe you can ask me via chat or like you can try to think about it yourself also. Yeah. I hope you'll be able to get it. So yeah. So maybe I can underline this also because I think this will be a good exercise for you guys. So yeah. And I've already given the intuition behind this also. So you should be able to do this. Okay, so now let's come to the fourth question. Fourth question is a pretty straightforward question. So Rasika, would you like to answer? So function do something is an example of a greedy algorithm, divide and conquer, DP, or none of these. Yeah, so it's a DP algorithm. So first of all, we are just talking in this session only about DPs anyways. And also it's easy to see that what we are doing is we are using recursion along with memoizing. So that's why it's a DP. Option C. So yeah. As we are using recursion with memoizing. Something like this. Okay, so next fifth question is also not too difficult. Rasika, would you like to answer this? So, what is the time complexity of the function do something? Okay, maybe I should say B. So this was the do something function, which was running these two nested for loops, and in each of these entries, there was a constant time operation being done. So what's the time complexity? So Rasika is saying option C, which is order element. So I guess this is also easy to see why, because outer loop runs for m times, inner loop runs for n times, and inside each inner loop, we only have a constant amount of time operation. So yeah, so order element. Option C. So this is because outer loop. This is because there are nested loops where the outer loop runs m times or maybe order m times. Inner loop runs order n times. Inside and constant and order one amount of work is done in each iteration. So there are so outer loop runs m times, inner loop n times. So there are something like order mn total iterations, and order one amount of work is done in each iteration. So time complexity is order something like this. I think it's quite straightforward to see also. So okay, so we come to the last set of questions for the day. So like the question 6 and 7 will be based on this paragraph. So this is, I believe, from your ungraded assignment. So I just want to discuss this also with you guys. So this is the common statement for problem 6 and 7. So the question asks us, so it builds up a storyline first of all, like your final exams are going to be over and you're catching up on Netflix. You have a schedule of interesting live shows from all over the world during the next week. You hate to start or stop a shoot, stop watching a show midway. So your aim is to watch as many complete shows as possible during the week. So what we have is we have n shows given to us, which are going on in the upcoming week, and shows are ordered according to their starting time. So basically for each I, so mi the show mi starts before the show uh, mi plus one. So something like this. However, show mi may not end before mi plus one starts. So yeah. So what this actually means is even though the show mi may start earlier, end later than mi plus 1, right? Because a show can go on for longer. So what this actually means is, and so because of this, we are given an array next. So it is also given to us as input only. So next I is the smallest j greater than I, such that mj starts after mi finishes. So basically, next I, what does next I give us? Next I gives us the uh, earliest show, which starts just after uh, ith show. Like after ith show ends, like if I'm so what this next is actually giving us is, suppose I watch this show mi, and after this watching the show mi, I want to find out the show which starts the earliest again. So this is what next I gives to us. Like it's the smallest show index such that that show starts after mi finishes. So yeah. So now given the sequence m1 to mn and the values next I, so these are already given to us as input. Your aim is to compute the maximum number of complete shows that can be watched. So now what we want to do is, so we are sort of given these show schedules. So we are given the starting time of each show. And we are also given like if one show ends, what's the uh, earliest show which I can watch after this show. So, and now we want to find out the maximum number of complete shows which we want to, which can be watched. So for this problem, so again, this problem will entail a dynamic programming based solution. And the sixth question is sort of giving us an intuition of how to build up this solution. So let watch I denote the maximum number of complete shows that can be watched among mi plus 1 till mn. So suppose we consider only these shows. So watch I denotes the maximum number of shows which can be watched out of these shows. And now we will need to give a recursive formulation for watch I. This is what we do in DP if we give a recursion and then try to memorize. And assume that base case is watch of n is 1. So if we are given just one show mn, then we can obviously watch it. So that's why watch of n is 1. So now we want to give a recursive formulation as to how can I update this watch I. Suppose I have this watch I with me. Now I want to find out what's the maximum number of complete shows that I can watch. So there are four options for the correct recursive formulation. Maybe I can give an intuition also for this. So there are two choices, right? Suppose we are only given these shows, mi plus 1 till mn. So there are two choices, and what are the choices? Either I can watch the show mi or I can skip the show mi. Like either I choose to watch the show mi or I choose to not watch the show mi. So if I don't watch the show mi, then I just have to maximize out of this set, maximize the number of shows out of this set, which is nothing but equal to watch of I plus 1. So watch I will be max of two terms, where one term will be watch of I plus 1. And the second case can be, suppose I indeed choose to watch the show mi. Suppose I choose to watch this show mi, then what happens is, so if I watch mi, there it may be possible that I am not able to watch mi plus 1, mi plus 2, and so on. And what is the next possible show which I'll be able to watch? It will be the show next I, because next I gives me the smallest j which I'll be able to watch. So if I choose to watch mi, then next I will be the next show which I'll be able to watch. So the problem now reduces to something like something like, let's say next I comes something like here. So now from m of next I to mn, I need to watch the maximum possible number of shows. So I hope what I'm trying to say makes a bit of sense. So what I'm saying is, if I choose to watch mi, then there will be some shows which I won't be able to watch here, but there will be a show mi next I here that I'll actually be able to watch. And after that, I'll be able to watch all the shows, because since these shows are sorted according to starting time, so if I'm able to watch, let's say next I, then I'll be also be able to watch next I plus 1, next I plus 2, and so on, just after mi. So what this means is that the problem will just reduce to watch of m. So watch of next of I. The problem will just reduce to watch of next of I, because from these next of I to mn I can watch. I need to watch maximum number of shows, and I'll add one to it because I've already watched mi. So the option will be something like max of watch I plus one, comma one plus watch of next of I. So this is something which I claim should be the correct answer. So is it clear what I'm trying to say? So watch I plus one, this term will be because suppose I choose to skip watching this show mi, then I just have to maximize the number of shows from I plus one to n, which will be just watch I plus one. And if I choose to actually watch this show mi, then what this means is that I have watched already one show, and now I cannot watch any show before next of I. And from next of I can watch any show afterwards that. So that's why I watch of next of I. And one because I've already watched mi. So that's why watch I will be the max of these two things. Because there are two choices and I'll take the maximum because yeah. So I hope it's clear. And try to type this also. So the correct answer is option C. So we are having a lot of option C's here, I think. So here also option C, option C. This is also option C. So yeah. So option C. And why is this true? Because there are two choices for us. Either we watch the show mi or we don't watch mi. And for these two cases, maybe I can just, if we don't watch mi, okay, maybe I should, there will be two choices for us. We watch the show or we don't watch mi. So if we don't watch mi, then what happens is, then we need to maximize the number of shows from mi plus 1 to mn. From mi plus 1 to mn. This will be equal to watch I plus 1. So this will be nothing but equal to watch I plus 1. And what's the second case? If we watch mi, then we can't watch any show mj. Okay, sorry for this. Where j is less than next of I. So the maximum number of shows which we'll be able to watch is equals to 1 plus watch of something like next of I. So something like this. So these are the two cases, and now we take the maximum of the two cases to calculate watch I, as done in option C. So something like this. Okay, so that's how we obtain the option C as the correct answer. Max or watch up next so and watch up I plus one for all I. So I hope this is clear. So something like this is the correct answer. So if this is clear, then maybe we can move on to the last question for the day. So if this is not clear, you can ask me in chat and I'll try to explain it again. Otherwise, I'll just assume like always that it's clear. So the seventh question says that how much time will it take to compute the answer using dynamic programming? Assume you have direct access to the next array as well, and you don't have to worry about computing it on your own. So the problem says that suppose we are given given this next array as input. Now, how much time will this recursive function, will this option C recursion take to compute on our own? So like if we want to calculate this watch of n, what will be the time complexity for this? Any idea? Okay, so Rasika is saying in the chat that the answer should be option D, it's order n. So that is correct, Rasika. So good job. So to find out watch of I, what we just need is the value watch of next of I and watch of I plus one. This can be fetched in order one time. We know that next of I is available to us already in order one time. So watch of next of I is also in order one. So this can be done in order one time. So yeah. So yeah. So answer is option D. Option D. And this is because each entry of watch array can be computed in order one time. And so finding the computing the watch array takes order n. So and that's why option B is the correct answer. So, okay, so I guess I only had these questions for the day. So yeah. So these were again some different questions from last time. Last time we discussed dynamic programming only, but knapsack type problems. This time we were discussing some different sorts of problems, like we discussed string algorithm, we discussed something like the scheduling algorithm, and similarly we discussed something like longest increasing subsequence and stuff like this. So I hope these problems will be helpful to you guys in this assignment, in this week's assignment. So I guess this was it from my side for today. So Rasika, if you have any doubts for the session or just any doubts in general or any comments, maybe you can ask it since we have a bit of time, or otherwise we can close the session also. Okay, so Rasika is asking, so what kind of questions can we expect for the exam? So I'm not too sure about the questions of the examination because like I haven't personally seen the NPTEL exam, but yeah, they will be definitely be similar to the kind you are solving for assignments because these are the types of questions these are the types of questions which will be expected to solve in the exam also. So like if you are able to, if you are closely following all the assignments and doing those by yourself, I believe you will be quite good for the exam. Like you will be quite good, well prepared for the exam. So yeah, like practicing these questions, these assignment questions is, I would say, a prerequisite. Like I think if you have done these thoroughly, then there shouldn't be any issues in the exam. So they won't be obviously same as the one you're solving, but yeah, they will be similar in flavor. So yeah. So that's why like understanding the theory behind all of these is also important. Just not the answer, because if some value changes or something changes, then also you should be able to accommodate and answer accordingly. So I hope I've answered. I hope the it's clear to you, Rasika. Okay. So if you have any other doubts or comments, uh, Rasika, maybe you can ask. Otherwise, we can also close the session. Okay, so Rasika is saying that she has no doubt. Okay, so I guess then this is it for today. So once again, Rasika, thanks for joining, and hopefully we'll see you next week also, like Tuesday, same time, 6 to 8 p.m. So till then, like I guess all the best for assignments, and maybe you can leave the session also right now, and I'll also just stop recording and close the meeting. So yeah, thanks for joining, Rasika. Bye bye.